Hello, my name is Zhang Shuhan, and today I will introduce the method that I use to solve the question 8 on homework 7. The question 8 gives us a Poisson precise, which is defined by the following properties. The first, we have the interval of t and t1, and the interval denoted as t. The Poisson random variable with parameter lambda t is defined like this. And second, in the intervals of t1, t2, and t3, t4, if these two intervals are non-overlapping, then the random variables n t1, t2, and n t2, t3, t4 are independent. And the third properties is at a time moment t, and there is no more one Poisson point. Using the point ti, we form the stochastic process xt equals to n 0t, and the graph is shown like this. And the first question is to find the expectation of big xt, and the third question is to find the autocorrelation of t1, t2. So let's focus on the questions as we solved on chapter 4. First, if you have a Poisson distribution like this, it's a density functions of Poisson distribution. So the summation of the Poisson probability should be equals to 1, and we multiply e to the power of lambda on both sides. We get this, and we take derivative of both sides. We have the equations here, and then we multiply lambda at both sides, which we have these equations, and then we divide the e to the power of lambda on both sides. We have these functions. These functions denote the expectation of big X should equals to lambda, and since in these questions we have the lambda t, so we just simply replace the lambda with lambda t, and we can get the expectation of big xt is lambda t. And then we need to find the autocorrelation of this Poisson distribution. First, we apply the variance equations, which is expectation of x minus lambda to the power of 2, and we can write the variance in these equations and apply lambda equals to eta, and we get these functions. In order to solve the expectation of x squared, we can also use a differentiate method on the both sides. We can get these equations, and then we divide the e to the power of lambda on both sides. We get these functions. These functions means that the expectation of x squared equals to lambda times 1 plus lambda. And in these stochastic questions, we just replace lambda with lambda t, and we get the expectation of x squared, xt squared should equals to this. And first, we need to solve the autocorrelations. First, we suppose that T2 is larger than T1, and we write the definition of autocorrelations. Then we can do some tricks on the x2. We use x2 minus T1 and plus xt1, and we write this into details, and we get this. since we have the excitation of xt1 and excitation of xt2, and also we have the excitation of xt square, so we just simply apply t1, t2 to the equations that we solved above, and we get these equations, and then we do some simplification. The final result of correlation of T1, T2 when T2 is larger than T1 should equals to lambda times T1 plus lambda T1, T2. And for the other conditions, when T1 is larger than T2, the autocorrelation should be lambda times T1 plus T1, T2 lambda. And sorry, for for T1 larger than T2, we can use the same method to solve these autocorrelations. The result should be lambda times T2 plus T1 T2 lambda, and we can easily find that the autocorrelation of the autocorrelation of the whole definition region should be lambda times the minimum of T1 T2 plus T1 T2 lambda. And that's all. Thank you.